So one of the things that we focus on is really just how do we better perform to increase the efficiencies of our customers. When we first got introduced to international mold steel, what we found to be quite attractive was that this modified H-13 had a very high thermal conductivity. So it was about double that of what the other printed steel powders were. So that was quite attractive for us because we want to be able to not only provide conformal cooling, but there's some things that conformal cooling just can't get to effectively. So we really want to use the benefit of the conformal cooling, but also drive other higher thermal conductivity applications in true tool steels that are going to not only provide excellent wear and longevity, but also provide the thermal conductivity, which drives out the cycle time and keeps the molds cool. So that was really how we found the HTC 45, and we started on that journey of qualification, and through that qualification process was really when we saw the true benefits of it and how well it printed once we got the parameters dialed in.
Okay, I believe this started with a presentation that we made at Amerimold 2019 when this powder was being released to the market. Jason came to us and said, I have an interest in this. And of course, he was early. So I would say he was an early adopter. We were happy to supply him with the information, with the powder for him to qualify. So we would have given him some basic parameters, which he would have used to apply to his equipment and his setup. And then we've just stayed in close touch since then. As things have come up, shared information back and forth. And now we're to the point where we're starting to produce parts for customers. It's been a great relationship, it really has.
Yeah, I think it's real important. I'd say first and foremost the die cast industry. So really in die casting for additive manufacturing, it's Maroesian steel or Maroesian steel. So having another alternate to that with something with a higher thermal conductivity, what that's going to produce is better thermal dissipation. That thermal dissipation is going to go towards things like elimination of solder through better conformal cooling. It's going to take out those hot spots. It's going to reduce the heat checking because you're pulling the heat away and not building the heat up. So that's going to extend the die life. So I think die cast is something the die casters should be looking at, both from the die maker side as well as the production side. So for replacement inserts or new dies where you see those hot spots and you're not able to cool, that really is probably one of the best areas we've seen. Other areas, again, it's difficult to cool. So we have some areas where maybe it's, just from a steel standpoint, on the injection molding side, you just can't get a good cooling up in there because, again, you're going to have the wall of steel, you're going to have the cooling circuit, and then the outer wall of steel again. And in that space, just the physics of the steel and the strength of the steel and the injection pressures. So there's a lot of areas where we have, very tall steel, just like this insert here, tall inserts, very thin steel applications where you're not going to be able to get maybe right up to the end the conformal cooling. So you really need that, thermal dissipation or that thermal conductivity to go that extra mile and pull that heat away for the kind of more higher performance molding applications.
One, just not understanding the process, not understanding conformal cooling. I mean, the notion of conformal cooling, I believe, it's been around for a while, but it hasn't been used significantly until recently. So you have a lot of tool makers who've been around for a while and they haven't gotten to that acceptance level yet. So the more we can educate them about the benefits and ideally prompt them into a trial, then they'll see. And once we get there, I think then the adoption curve goes up significantly. If there's one thing, I would say potentially the density of the build. So it's a metal powder and you wonder, is it going to have the same properties as a wrought steel? And the answer is yes, it will, and in some cases even better. but I would say that's the biggest one. Well, Jason, what do you think?
Yeah, I think the density, you know, again, over the last 2 decades has always been the prime thing. I think, you know, with the improvement in the lasers and the laser melting systems for direct metal laser additive, the ability to get the wattage density and other parameter sets in line, you know, again, the base parameters that are provided from Dido and from Doug and his team, you know, really is really the baseline that we use, but then also, again, it's that trial and error of going through that has enabled us to get to that higher level, that 99.99% density. By getting to those levels, it really kind of takes those issues that we've seen previously, or maybe other people have experienced in the past, it really eliminates those. So I think that's probably a common myth too. And I think the other myth that I see is a lot of you know, mold makers are applying, let's say, previous tribal knowledge or previous mold building standards to an additive manufacturing application. So there's rules of thumb or standards that have been applied over time. I'll give you an example. One might be the distance of the water line to the surface of the mold. You know, there's a rule of thumb there, and spacing. And again, with, you know, some of the technology and the advancements and the strengths being put in, we're looking at things that are more higher performing the more structural that they are. So being able to leverage higher strength through structural applications really, you know, makes things possible that traditionally were not ever possible. You know, I look at a core or maybe a sleeve like this. You know, we have a typical sleeve insert here. You know, thin wall, we're down to, you know, less than 2 millimeters on a wall thickness. You would never think or say, hey, you know, we're not going to be able to get cooling up in there. That'll never work. But we've actually, again, there's conformal cooling all up through this insert, right up to the tip. And what that does is right at the tip where one of the more difficult details is to mold, we can actually cool that effectively. So again, in the past, you know, the rules of thumb of keeping the cooling circuits a certain distance away or a certain spacing kind of goes out the door, because now we're dealing with higher structural, higher strength materials, and materials that are going to actually perform well when they're cooled well and not being, you know, thermally, you know, kind of pushed to the limits thermally and fatigue and causing cracking and failures, which we see in conventional tool steel. So those are a few, I would say, probably myths that we've seen and the experience that we have with printing additive. But again, I think there's a lot of other ones. You know, the maintenance issues is probably another one. So again, this is all great that we can look at this and build this, but a lot of people say, well, you know, I don't have great water. And the big myth is, you know, like nobody else has good water either. But there's some very simple things, you know, through basic filtration, ultrasonic cleaning of inserts, things that, you know, that we've done to try to educate customers on to eliminate those myths. So a lot of that information can be found in MoldMaking Technology magazine. Some great articles there that we've written to try to educate people on how to maintain the tooling. But again, the myths that, you know, these things, you know, water lines get blocked off or rust out or things like that. I mean, you know, regular tooling, that happens as well. So if you don't maintain your tooling, that's really the root cause.